Hello and welcome back. And in the previous video, we saw about the outliers. So let us remind ourselves again what are the outliers. So if we define the outliers, it's the set of data points that are significantly different from the other data points in a data set. They are values that are unusually high or low compared to the rest of the data. So any data point which is very much unusual compared to the other data points among those set of data points, if there is something which is very much unusual, very much high or very much low compared to the other data points, then these data points are known as the outliers, right? So these outliers, since we are using the outliers in our training data, in that case the outliers will impact our training model. Okay, so how to deal with these outliers? Because if we don't deal these outliers, then obviously our model is going to be impacted. When we will train our model with this data, then obviously the model will not be that effective. Its accuracy may be impacted. So what are the different ways to deal with the outliers? So the first method is to verify the data accuracy. So which means, like, if you get the data, once you get the data, you can easily find out if the data that you are getting as an outlier, is that an error? In fact, it may be that it's an error. It's a result of some kind of error. Some kind of misleading data has been placed here. Some kind of error is there due to which this data has come to you. In that case, you can remove that data, right? So either you will remove that data or you will transform the data, which is an outlier. So we will see what is the meaning of the transformation. Transformation means you need to, use a function to transform this data in such a manner so that it comes under the range of the acceptable values, right? But we need to see that what kind of transformation we should do so that any outlier can be considered within the expected range of values, or within the range of those values which are not the odd man out. What kind of transformation you have to do? So those kind of things also need to be considered. And there are some robust methods which ensures that that we are those methods are really resistant to the outliers. I mean, those methods are really helpful to spruce out those outliers which are not useful for you. So they are really they are very much resistant to the outliers. It is easily able to detect the outliers. These methods are easily able to detect those outliers, and then just remove them, or just detect them, and then you can just remove them, right? So the robust methods are easily telling you that this is the data which is an outlier, and this is something it should not be with you, right? So they are very much resistant to the outliers. They cannot accept those data points which are like the outliers, or the outliers. Okay, so the outliers can provide valuable insights into unusual pattern or in data. See, outliers are not always bad. They also provide valuable insights. It may be that they are providing some kind of information which is rarest of the rare, but that rarest of the rare is something which is, which can help you to predict some kind of thing, which is very much rare in certain conditions, right? Like, a kind of problem you can consider is the problem of identifying the sugar, or you can say the problem of diabetes among the people, right? So most of the people who are above the age of 35 or 40, they have the higher chances to have the diabetes. They can get the diabetes. So most of the data points will lie around 40, 50, 60, around these age distributions. So when the age is between 40 to 60, then only you will be able to see all the data points where the people have the diabetes. But it may be that some kind of outlier comes, and that outlier may be like a 5-year-old boy or a girl who has the diabetes. So in this case, this gives you a significant insight with this outlier data, right? That it's not like small children cannot get the diabetes. They can also get the diabetes. This is the rare case, and this is really important to know that the children could also get the diabetes. So this gives a valuable insight into the unusual pattern. So unusual pattern also have some kind of insight, right? So that is why the outliers must need to be understood correctly. They must need to be, just identified correctly to find out if they are really outliers or if they are really giving some valuable insight being an outlier, right? So identifying and addressing outliers is crucial for accurate data analysis. I don't think I need to explain this anymore, right? Because we have discussed enough now. So now we are going to see that how we deal with the outliers, right? Dealing with outliers. So here again, I have written it. So there are some common methods to handle the outliers, right? So there are two types of methods to handle the outliers. One is to detect the outliers. So those methods are known as the detection methods, right? So detection methods are those using which we can identify that if there is any outlier in your data, right? So one thing is like visual inspection. You can visually identify, you can plot a graph, and after plotting that graph, you can find out if you are able to see any odd man out, any data point which is outside the purview of the usual data. So that kind of visual inspection can help you. So among these methods, like in the detection methods, one is visual inspection, where we plot the scatter plot graphs and the box plots. So we are going to see these two methods, and this data we are, I mean, this piece of code I'm going to show you, right? So this piece of code I will provide you under the under somewhere in the resource section or in the comment section, so you can just take it from there, right? So I'm going to again use the Jupyter Lab. Jupyter Lab. Oh, why it's not identifying it? Okay, so let me see what are the methods to identify the Jupyter Lab. How? I think I have forgot the. Oh, Jupyter Notebook. I just forgot the command. Okay, so let me. Sorry for that. Jupyt Jupyter Notebook. So let's see. Once it starts, it will be able to launch the notebook. So here it comes. Let me close this. So here you go. So I'm just going to open the previous files. Yeah, untitled this one. So let me open this. This has been opened now. Jupyter Notebook, and let me just remove all these things which I have created. So let me do the visual inspection. Copy and paste. Before copying and paste, let me just do like in the different sections. So let me put it here. First section, let me see if we are able to find it out. Okay, we are able to do it. Then we are going to generate the sample data. So this will be generating the sample data. So what does this mean? So we are going to generate the sample data for the normal distribution. We have seen the normal distribution or the Gaussian distribution in the previous video, right? So here what we are going to do, we are going to generate some kind of random data, but we are ensuring that whatever random data we are generating, the standard deviation will always be 1 and the mean will always be 0. We have discussed everything like mean, the standard deviation, everything. And we have given like 100 records we are going to generate. And we have, just called np.random.seed, which is the numpy library method. So we have given a seed value 0, and from here, the values will be generated for this way, for this one, for the sample data. 0 will be the mean, 1 is the standard deviation, and 100 is the number of records we want to generate. Now, come to the next one. Next one is that we are going to add the outliers. We are going to add the outliers here. Outliers means, here we are giving some value like -5, 5, something like that. So we are adding in this set of data, like in X, we are adding some value which is outlier, which is not in the usual range. It will not come under the usual range, like the standard deviation will not be the standard deviation will be calculated, then this will not come as 1. And when the mean will be calculated, then mean will also be disturbed. It will not be 0 when I will include this data as well. So there is the data here which I have generated, and now I am adding the data in X and Y both, X axis and the Y axis. At both places I am adding some kind of data which is an outlier. And there are two values, -5 and 5, which I'm going to add in this, set of values. Let me see if it is running fine. So yes, it is running fine. Let me see why is it doing so. X is not defined. Let me see why is it doing so. And now, yeah, now it is running fine. There was something wrong. That is why it was giving me the problem. Now let me generate the scatter plot and then show the plot. Okay, so let me just run it. So here we are going to generate the scatter plot. Scatter plot, we will just see that how it looks like, and then we are setting the title and the labels. X-axis, Y-axis, just the random axis names, X-axis and Y-axis, because we are not going to give any name here. We don't have the real data. It's just data to demonstrate you. Then we are going to display the grid, and then we are going to plot it. So it will just show you that how it looks like. Don't worry. So let me run it. Here you see. Okay, so you can see there are some kind of values. These are the two values. One is this one and one is this one. -5 and +5, right? So something which is outside the range of these values, whatever we have plotted, these values, this is the scatter plot. I hope you know about the scatter plot. The points, the data points have been scattered throughout the x-axis and the y-axis. So on the x-axis and on the y-axis, we have added 2 points. One is -5 and the other one is 5. So it is significantly away from this set of data. Okay, so this is how you identify the outliers. So you can find out by writing this code, right? You don't have to write this code. You can simply plot the graph. On the x and the y axis, you can plot the feature and also the feature value x and y. Y means fx, the function of x. Both you can plot. This data we have generated, but you will already have some data with you. So you don't need to write this kind of thing. I hope you are understanding. This is very much understandable. Like this is the data that I have cooked, but you don't need the cooked up data because you will have the real data. So you need to plot the real data, and once you plot the data and you find out that there are few points which are significantly away from the usual data points in the data provided, then you can understand that yes, there are outliers. Okay, so this is one of the method for outlier detection, which is known as the scatter plot method, visual inspection scatter plot method. Now we are going to see the box plot method. In the box plot method, we have used the interquartile range that we have not studied yet. So we are going to discuss that in the coming videos. But yeah, I'm just going to show you that how the box plot looks like. right? Let me write this piece of code. Let me first remove all this piece of code which I have written for you. We remove it, remove it, remove it, remove it, and then I'm going to just write like this, import the two libraries. Let me run it. Then let me come to the next one, generate the sample data. So I'm again generating the sample data, right? You can see I have given the seed and then I'm generating the random data. Here you go. Then run it. So I don't need to tell you that what I'm doing here because I have already told you in the previous example. So I'm adding the outliers here, -5 and 5. And now let us see what else I need to do. I need to calculate the Q1, Q2 quartile range and the interquartile range. Quartile values and the interquartile range, both I have to calculate, right? So for the Q1 and Q3, these are the quartile values. So let me run it and let me show you. So what we can do, we can print Q1, then print Q2, and then print Q3. Oh, it's Q3. And then we have IQR. What are these values? Let us see. Okay, so here you go. So first thing is Q1 and then Q2. This is some kind of percentile value, right? So numpy dot percentile method, what does it do? You can find it out and then you will be able to understand that what kind of value it has given and why it has given this value. Similarly for Q3 and then interquartile range, we will discuss about this one in the coming videos. But as of now, just understand that this is the difference between Q3 and Qn. So basically, when you will find out the difference between Q3 and Qn, then it will come like this, 1.41. So this is the interquartile range, right? So interquartile range is basically some kind of point on your data, plot, whatever you are plotting, and that basically shows you the vicinity, right? I mean, the distance after which you need to consider some of the points. I know any point you need to consider as outlier, right? So interquartile range is in the vicinity, right? Like under the vicinity of this plus or minus anywhere. If you are plus 1.41 or minus 1.41 from any data point, and if some data point is outside this range in any direction, plus direction or negative direction, in that case, that particular data point will be known as the outlier, right? Now, let us see, identify the outlier. So how to identify the outlier? This has been written here, right? So here, identify the outlier. Data should be within the Q1 minus 1.5 into IQR. So here you go, like not only 1.4, we have assumed like 1.45 into IQR, right? Our data should be greater than Q3 plus 1.5 into IQR. So if your data is smaller than Q1 minus this, or data is going beyond this, then that data point will be considered as an outlier. We just discussed, right? So this 1.5, this all depends on like what kind of data you have and how you think, like how much vicinity you should decide, right? So based on the interquartile range. So we are going to discuss about that interquartile range in the coming videos, but here you only understand that interquartile range is just about defining the vicinity, right? The area of influence, you can say. If under that area some value comes, then it is not an outlier. If something is coming outside of that area, outside of that boundary in positive direction or in the negative direction, because this gives you, in the lower side and this gives you on the higher side. If the value is higher than this one or the value is lower than this one, then in both the cases, the data point that you are going to use or the data point that you are getting, that is simply an outlier. Let me run it again. And let us go to the next one where we are plotting the box plot. So let us see box plot. Let me run it. And now you can see. Here you go. So this is the box plot. And this point +5 and this point -5. We added point -5 and 5, right? So these 2 points are outside the vicinity, right? So this was the interquartile range 0.14 here in this direction, this line, right? 1.4, and this one was -1.4. And now this value, this range that you are able to see like this one, this is basically getting off. This is basically we are getting after multiplying 1.5 into the interquartile range, which was 1.4. So this is that value which we get after multiplying 1.5 with the interquartile range. And these are the values which are, you know, far away from the values, right? These are far away from the values from the vicinity. So this is the vicinity. I want everything to be inside this range. If anything goes beyond this or beyond this, then this is an outlier. Like this one is an outlier, this one is an outlier. So we have just identified the outlier here. So I hope you must have understood that how we are identifying the outlier here. I will provide you this piece of code so that you can simply run it and test it at your end. But yeah, I hope you are getting the point here that how we are doing it. So with this, I would like to say have a nice day and bye bye, and we'll meet you soon in the next video. Till then, have a nice day. Thank you.